Good afternoon, I'm Jim Baird. I'm a teacher here at Jones Technical Institute, or JTech. Today we're going to talk a little bit about the oxygen sensor. Not so much the oxygen sensor itself and what it does, but a little bit more about how it works. And this is going to be kind of generic because all the oxygen sensors have the same principle of operation, but one manufacturer may be different from another. So just to get started, generally, oxygen sensor, we see them in the vehicles. We've got a portion that actually threads into the exhaust system, and then we've got a pigtail, and then it connects to the wiring harness. So the oxygen sensor is located in the exhaust system before the catalytic converter and just after the catalytic converter. Now why before and after? Well, the one before is going to be measuring engine performance. We want to know how the engine is running and how our air-fuel mixture ratios are going. Then we have the catalytic converter, which cleans up the exhaust, or it's designed to. And then we have a post-catalytic oxygen sensor. And the idea is that by using this one, we can measure the exhaust coming out of the catalytic converter. I can compare the two together. The ECM can make modifications to the way that the engine runs. The oxygen sensor, like I said, is before and after the catalytic converter. I mentioned that the catalytic converter is going to clean up the exhaust. So inside I've got a honeycomb, and you can see that this drawing is kind of a cutaway. So the exhaust is going to flow from the engine past the first oxygen sensor. It's going to send an input to the ECM. It's going to go through the catalyst, and there's going to be a chemical reaction. The molecules inside the exhaust are going to be attracted to the materials in the catalytic converter. Things are going to change. Some of the molecules are going to recombine. They're going to create different elements, and they're going to go out the exhaust. The idea is to have no pollution going out in the atmosphere. So pre and post catalytic oxygen sensors. So here's a drawing that's kind of a cutaway of an oxygen sensor. And it's a little complicated. On this end, we've got a metal shroud. So if we go back to the first drawing in your mind, there's little slots where the oxygen or the exhaust will flow past. So we've got an area here, this blue section is actually where the first part of the sampling is going to occur. This light blue rod here is actually a heater. Now originally oxygen sensors just monitored the exhaust. We kind of worked with it a little bit, but the engine didn't worry about what was coming out of the catalytic converter. So later we decided that that was more important, to measure both before and after. So they put a heater in there so that this would warm up to temperature and the chemical processes inside the oxygen sensor could occur sooner. Because that time when we first start the car, there's a period where we do a little bit more pollution than when it's up to temperature and everything is working properly. All right, so what I've got here is, here's a kind of a diagram that's going to show a volt ohm meter, and I'll talk a little bit more about that in just a second. So what I'm going to do is I'm going to measure the voltage from this element, and I'm going to compare them. And that's going to give a reading to the computer to tell me the ratio of the oxygen fuel. All right, so it's called a Nernst cell. So basically what I'm going to do is, this is my oxygen sensor, and I've got exhaust flowing past it. So on one side, I've got my exhaust, and then on the other side, inside of my oxygen sensor, inside this thin layer here is fresh air that comes from outside of the exhaust. Flows down into this chamber, so now I've got a way to measure a comparison between the fresh air and the exhaust, so I can compare the two. So because I can compare the fresh air and the exhaust, I can do a contrast. So what we got here is the elements that are in my exhaust are going to react with this layer, and they're going to create a chemical reaction that's going to change the way that this material conducts electricity. And then in the oxygen, the atmosphere side, the same thing. So the two are going to compare. So in this diagram, I've got one that's lean, which means that there's not a lot of fuel, it's well burned. We've got some oxides, and we've got some nitrogen oxides and O2. So that means that there's not enough fuel in there. So the engine needs to compensate by giving it more fuel. To contrast, this side has got a lot of hydrocarbons in it, a lot of hydrogen. It's running rich. So the engine says that because there's a lot of those elements compared to the oxygen, it gives me a different voltage reference, and then the engine needs to lean up. First thing is we need to look at how the ECM can figure this out. So I put a number line up here and a voltmeter. So a voltmeter doesn't really measure voltage. What it measures is the difference in potential, or the difference between one voltage and another. So on a common battery, let's say that my negative terminal is 0 volts. And I'm going to go over here to the other end of a sensor, and I put my leads. So what I'm reading is the difference between here and here, which in this case is 7. So I've got a difference of potential of 7 volts. So it would show 7 volts on my meter. That's pretty easy, right? Now sometimes we'll do a comparison and it's a different reading or a different set of parameters. So what's the difference here? My negative side is showing 2 volts and my positive side is showing 7 volts. So what's the difference? 5 volts, right? So I would have a 5 volt reference. Even though I have 7 volts on the high end, my difference is 5 volts, so that's what the meter would read. The same kind of thing is happening in the NERD cell inside of the oxygen sensor. So if I put my meter on here and I read this area and then the other side of the NERD cell where I've got the contrasting voltages, if this is 0 and this is, so the negative side is showing 0 and the positive side is showing 0.6 volts. So what's my difference in potential? 0.6 volts. So if I think about how my oxygen sensor works, and it works basically on a lambda cycle. So what that means is that I'm going to vary between 0, 1 volt, and anything in between. So a 0.5 would be perfectly in the middle between 0 and 1 volt. So I want to hover in that range. Normally, we have a switching point of 0.45 volts. So at 0.45 volts on this graph, now this is showing it in millivolts, but obviously 500 millivolts is half a volt, right? So this is the switch point. So if I have a reading that's, in this case, I'm showing about, I don't know, 575 or 0.575. So that would mean that I'm going to show that I've got a high potential difference in between the two sides of the cell, which means that I was rich. If I have a rich condition, the ECM says, okay, I've got too much fuel, I need to cut back on the amount of fuel that I'm going to put into the engine and lean up the exhaust. Now, this happens very quickly, 10 or 15 times a second. So this reading here is going to happen over and over and over again. So if I'm watching this cycle while the engine's running, I can see, and this is less than a second. So in less than a second, I see that my voltages are going to go up and down and up and down. And I want to try and stay right around that sweet spot of half a volt. So if it goes up above a half a volt, then I'm rich. If it drops below a half a volt, then I'm starting to get lean. And I want to try and stay in that sweet zone, right in the middle. So as it adjusts, so that means that it went rich. That means the engine leaned out. So then the next thing is I'm showing that the exhaust is lean. And it's going to bounce around. So anytime that occurs within a period that's less than a second, we call that short-term fuel trim. So the ECM is going to monitor that. And then I've got another layer where I'm going to watch that's greater than a second. So if these trim are moving up and down, and this is actually a good clean signal, occasionally I'll get to a point, all right, let's say I've got if I've got a problem with a connector and there's some corrosion, and the engine thinks that the exhaust is rich because my voltage went up. So I'm going to have a high voltage reading, and after it happens for more than a second, then it's going to be on my long-term fuel trim. And if it continues to do that, if I start getting into like 10 consecutive seconds where I have a high long-term fuel trim, then it can set a code. Then the ECM would alert the driver that there's a problem with the emission system. Any questions? Email me.